Right, so this is a picture from your formula sheet. So you'll have this on the regular exams to help you with naming chemicals. And I would start from the right side and work back to the left. The far right side at the top talks about acids. And the first thing you want to do is identify what kind of chemical do you have. And remember, if the chemical starts with an H, then it's most likely going to be an acid. If it doesn't start with an H, then you go to the middle column, which is molecular compounds. And molecular compounds are made up of only nonmetals. So technically, acids would fall as a subcategory of a molecular compound, but for naming purposes, if the chemical starts with an H, we name it as an acid. If it doesn't start with an H, but it still contains only nonmetals, we're going to name it as a molecular compound. And if it's not an acid and it's not molecular, then it must be ionic. And remember, ionic compounds are composed of cations and anions. You want to be able to follow the flow chart and understand what it means. So let's say we're talking about an acid. The first break in the flow chart takes you to either binary or oxyacid. And remember, binary was hydrogen with one other element. So the example at the bottom, HCl, and we name that always with the prefix hydro. The nonmetal changes its ending to an ic, and then you have a space and acid. So HCl, hydrochloric acid. If the acid is not binary, it must contain an oxygen, and the oxygen will be from a polyatomic that either ended in an ate or an ite. If the polyatomic had an ending that was an ate, then we change the ending to ic. For example, PO4 is phosphate. We change the ending to ic. So H3PO4 is phosphoric, then the space acid. However, if the polyatomic was an ite, it changes to an OUS. So instead of an ending like phosphate, let's say we had sulfite. The sulfite anion is going to turn into sulfurous acid. If it's not an acid and you're looking at a chemical that contains only nonmetals, then right away you should think to yourself, I have to use the prefixes. The first element doesn't change its ending. The second one changes its ending to IDE. So the example they give, diphosphorus pentoxide. Pentaoxide, it sounds better to change the A and O next to each other to pentoxide. Notice this is the same flow chart that you have, except you don't have the examples on your formula sheet for the exams. So you want to be able to use the one that you have posted when you're working problems. And then the last choice is the chemical is ionic. If the chemical is ionic, it asks you, does the metal form only one type of ion or does it form more than one? And the key here is whether you need Roman numerals for chemicals such as iron, which you can't predict the charge from the periodic table, that means you need Roman numerals. If you can predict the charge, you know what it is from the periodic table, chemical like calcium iodide, then you do not include the Roman numerals.